In August 2018, U.S. Senator John McCain passed away after a year-long struggle with glioblastoma. He was one of over 20,000 patients that year that suffered and passed from that horrible type of brain tumor. Glioblastoma is also called the terminator in the brain because patients on average survive for only 1 year. During that time, they have to go through surgery, radiation, and chemotherapy. Only very few patients survive for 5 years or longer. But why? What makes glioblastoma so different from other types of cancer? Well, there's two things. First, glioblastoma is very aggressive, and the tumor cells can spread out through your entire brain. We can't see those cells, so we can't remove them during the surgery, and they can regrow. And second, the tumor cells hide behind the blood-brain barrier. But what does that mean? Well, imagine this. Your brain is like a club, and to make sure that only the right kind of people get in, you have several layers of security. There's a wall around it that makes it basically impossible to snake in. But as a second layer of defense, there's bouncers that walk the perimeter and check everybody. If you're not on the list, they toss you right back out. The blood-brain barrier, these bouncers are called efflux transporters. Now, back to glioblastoma. The drugs that we use to treat the tumors are not on the list for the club, so the bouncers remove them from the brain. Therefore, the drugs cannot attack the tumor and do their jobs. So, what can we do about that? A lot of time and effort has gone into developing so-called inhibitors. And those are basically like shackles that are supposed to stop the bouncers from running after the drugs and removing them from the brain. But a lot of them can still catch up with the drugs and remove them, so that didn't really work. In our laboratory, we're working on a new and different strategy to allow anti-cancer drugs to get into the brain to treat glioblastoma. So, how does this work? Everything in your body is constantly communicating with each other to make sure that everything runs very smoothly. One of these pathways is called the PI3 kinase and ACT pathway. This is how it works. Basically, one little machine tells the next little machine, tells the next little machine what to do. It's basically like a game of telephone. If we block one of those little phones, we can prevent the bouncers from showing up for work. Without the bouncers, the drug can get into the brain and attack the tumor. The next day, a new work schedule is released, new bouncers show up, and keep the brain safe and protected for the majority of the time. We believe that this strategy can A, improve the amount of drug that gets into the brain, which will stop the tumor from growing, which will, most importantly, significantly improve the survival of patients like Senator McCain, hopefully even past the 5-year mark. Thank you.